Hello everyone, I'm Paul and today we're solving problem 3347, maximum frequency of an element after performing operations 2. This is a hard one, so next I will show you how to solve this step by step. If you haven't seen part 1 yet, I recommend you to go and watch that video first. It's in my channel. This is exactly the same as part 1, the only difference is down here in the constraints. We are given an integer array nums, an integer k, and an integer num operations. We need to return the maximum possible frequency of any element in this array after performing num operations times this operation. We have to select an index that was not selected in previous operations and add an integer in the range from -k to +k to the corresponding number. So let's say we pick 7. We can add or subtract up to 2. So from 7 we can go to 6, to 5, to 8 or 9. One possible result here is we replace this with 7, we subtract 1 from here because k is 2 and the new value is 7. And now here we have 3 equal elements. This is the maximum possible frequency of an element that we can get for this input, so we return 3. The only difference with part 1 is that every number can be up to 10 to the power of 9 and the same goes for k. And this is too much. Remember, for part 1 we were iterating every number as a target from the minimum number to the maximum number. But here this range can be very big. 10 to the power of 9 is a very big number. So we need to think about something more efficient. And the main question here is, what is the perfect target? And we basically have two choices. The target is either one of the numbers in this array, or it's a number that's not currently in this array. Let's see what I mean here. The result in this case is we can take 6 as a target, so we replace this with 6, this with 6. We could also take 7 as a target. We replace these 2 with 7. We could take 8, so we replace this with 8 and these 2. So this is the first scenario. Here the target is in the array. Now let's say we don't have these elements. We only have these 2. K is still 2. And the result in this case is 2. Why? Well, because the target in this case is 3. We can add 2 here, so the new value is 3. And we can subtract 2 from here and the new value is 3. Now we have 2 equal values and this is the maximum possible frequency that we can get for this array, so the result in this case is 2. And the target here is 3. And 3 was not in this array originally. So this is the second case. So let's go with the first case. Here we have the same array and 2 pointers left and right. They are initially here at index 0. And we are iterating every element, and every time we are checking if nums at right is smaller or equal to the current number plus k, we update right. So we are standing at 1. This means we can replace this number with anything in the range from 1 minus 2, meaning -1, to 1 plus 2, 3. So we are updating the right pointer until we reach a number that's greater than this right bound. Now the right pointer is here, we have a 5 and 5 is greater than 3. So now we stop updating right. How many elements do we have here? Well, we have right minus left elements. Right is at index 1, left is at index 0, so we have 1 element. And the question now is, what's the maximum number of equal elements that we can get with this element? And the answer is only 1. So the result was initially 0, and right now it's the maximum between 1 and 0, meaning 1. And here we only have one number 1, but remember that we could have many repeated values, so we need to keep track of repeated values. For this we'll have a frequency map. And every time we update the right pointer, we add 1 to the corresponding key in the frequency map. So first we were here, we moved right 1 step to the right. This means we need to go to the frequency map at 1 and add 1. Now right is here. And what we are doing here technically is we are taking the amount of elements in this array, which is index 1 minus index 0, meaning 1 element. And from here we subtract the frequency for the target, which is 1. And this is 0. So we need 0 operations as a maximum to make all elements equal in this range. And the minimum between 0 and the number of operations that we have available is 0. So in this case, the result is the frequency for the target, 1, plus the minimum of this and this, which is 0. And this is 1. And now we take the maximum between this and the previous result, 0, which is 1. That's why here we have a 1. Now the target is 5, meaning we can replace this with anything in the range from 5 minus 2, meaning 3, to 5 plus 2, 7. So we are moving the right pointer to the right until numsat right is greater than this right bound. And at each step we are adding the corresponding frequency to our frequency map. So first we are standing here and we are about to move right. So we put this as a key with a count of 1. Now we are here, so we add 6 with a count of 1. Now we are here and this is the right bound, so we add 7 with a count of 1. And now we are here, 8 is out of bounds. And now we need to move the left pointer to the right until numsat left is greater or equal to the left bound, in this case 3. Right now 1 is more than 3, so we move left. And given that now we are removing this from the window, we need to remove the corresponding frequency from our frequency map. So we subtract 1 and this is 0. Now left is here and we have 3 elements. How do we get the amount of elements? Well, we do right, which is 4, minus left, which is 1. This is 3 and we need to subtract the frequency for the target, because remember, we are not using operations for the target. So we subtract 1, which is the frequency for 5, and this is 2. Meaning in this window we can use 2 operations as a maximum. The result for this window is, well, the frequency for the target, which is 1, plus the minimum of the maximum amount of operations we could use and num operations. And this is 2, so the result is 3. And 3 is greater than the current result, so we replace this with 3. Now this is the target, so we could replace this with anything in the range from 6 minus 2, which is 4, to 6 plus 2, 8. So we are checking if numsat right is smaller or equal to this right bound, and it is. So we add 8 to the map with a count of 1 and we move the right pointer. Now right is here out of bounds at index 5. And we are moving the left pointer until it's greater or equal to this left bound. Right now it's 5 and 5 is within this range, so we keep left here. So how many elements do we have here? Well, right is 5 minus left is 1 and this is 4. We have these 4 elements. And if we subtract the frequency for the target, meaning 1, this is 3. We could use 3 operations as a maximum for this, this, and this to make all numbers equal. So now the result for this window will be the frequency for the target, 1, plus the minimum between the maximum amount of operations we could use and num operations. And this is 2. 1 plus 2 is 3, and the maximum between 3 and the result is 3. So we keep 3 here and continue. Next, this is the target, the window stays the same, so the result stays at 3 and we continue. Finally, this is the target, right is already out of bounds and left is, we need to move left because 8 minus 2 is 6 and 5 is more than 6, so we move left, but before we go to nums at 5 and subtract 1 from here, this is 0. Now we move the left pointer. Now this is the window, this is the frequency map for this window, and here, well, we could replace these two numbers with the target with an 8 because they are in bounds and we have two operations available, so the result in this case would be 3, and 3 is the result, so we continue. And now we are trying the second case. Here we are trying targets that are not in this array initially. We have two pointers, left and right. They are initially here at index 0 again. And right now we have two operations available. We only have one element, so we could transform this into some other element that's not 1 and that's in the range from 1 minus 2 and 1 plus 2. So right now the result for this window would be 1. And we can update right. We keep 3 in the result because 3 is greater than 1. Now right is here and we are checking if this is a valid window. And it is, because k is 2, so we could add 2 here and subtract 2 from here. We will transform this into a 3 and this into a 3 also. And here we will get 2 equal elements. So the result in this case for this window would be 2. 2 is more than 3, so this is not relevant, but I want to show you how this is a valid window. So we will update left until the window is valid. Right now it's valid, so we continue and update right. Now right is here and we are checking if this window is valid. We take nums at left, which is 1, plus 2 times k, which is 2. Remember, this is the same we did a few seconds ago. 2 times 2 is 4, plus 1 is 5. So the right bound from this point is 5, and 6 is greater than this right bound. So at this point we need to update left. Now left is here and this is a valid window. We could transform these two elements into 7, for example. And the result for this window would be 2, which is more than 3, so we continue and update right. Now right is here and we are checking if this is a valid window. So we take nums at left, which is 5, plus 2 times k, which is 2. And this is 9. And 7 is more than 9, so we are in bounds. This is a valid window. We could use operations for each of these elements, and this will require 3 operations, but we only have 2 available. So the result for this window will be the minimum between 3 and 2, which is 2. And the maximum between 3 and 2 is 3, so we keep 3 here and continue. Now right is here and we are checking if this is a valid window. So we take nums at left, which is 5, plus 2 times 2, and this is 9. So we could get all equal numbers here. Now the thing is that we have 2 available operations and the minimum between 4 and 2 is 2. And the maximum between 2 and 3 is 3, so we keep 3 in the result. Finally, we update right, we reach the end and we return 3. And by doing this approach with 2 different cases, we are reducing the complexity to big O of n log n. And space complexity in this case will be big O of n. Remember, we need to sort this and we also need a frequency map. So with this in mind, let's go with the code. First, we need to sort nums, so nums.sort. N is the length of nums and the result is initially 0. Now we go with the first case. Here the target is in the array, in the original array in nums. And first we have a frequency map. This is a default dictionary with a default value of 0 for every key. And we have 2 pointers, left is 0, right is 0, and for every number in nums, first we update the right pointer. While right is smaller than n and nums at right is smaller or equal to the right bound, which is x plus k, the frequency map for nums at right plus equal 1, and we update right, of course. Now regarding left, while left is more than n and nums left is smaller than the left bound, x minus k, the frequency map for nums at left minus equal 1, and of course we update left. Every time we have a maximum number of operations that we could use, and this is given by the amount of elements, meaning right minus left, minus the frequency for the current number. And the result every time will be the maximum between the result and the minimum of max operations and num operations plus the frequency for the current number. Now we go with the second case, which is target is not in the array. And well, remember that the array is the array nums. Here we have 2 pointers, left is 0 and right is also 0, but we are moving right every time, so we can say for right in range n, and every time we are making sure that the current window is valid. So while left is smaller than n and nums left plus k times 2 is smaller than nums right, we update left. Now we have a valid window every time, so we can do the same as before. The maximum number of operations that we could use is given by the amount of elements in the window. This is right minus left plus 1. And the result is the maximum between the result and the minimum between the maximum number of operations. We are using 1 operation per element here because here the hypothesis is that the target is not in the array. And we take the minimum between this and num operations. Finally, we return result. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.